TU.com.
So in this video I'm going to explain about active HTML software programming procedures. Okay, so this is a software active HTML, so it is from Altec. So this software size is 537 MB. It is a student version. Okay, it is easily you can download in that website. Okay, so you have to give some registration by your email ID and you can download. Then after installation, this is a icon to open a software. Okay, open the software first. So this is a student version, so it has some limitation. We cannot do all the we cannot use all the features in this software. Okay, right, some features are one full versions only. Okay, in student version it is a limited, but it is enough to the students. Okay, so initially it will come on, it shows a message. Okay, I understood that I may use active HTML student edition only for educational purpose and any other use. Okay, this is some message shown, then give OK. Then it is a logo, likewise it will open. Actually this software is available in our link. Okay, in our link you can find this software and you can download without any registration. So it takes some seconds to open. If you have a high configuration computer, means it will open soon. Okay, here it's my laptop having low RAM, so that it is open slowly. Okay, right. So this is a window. Here it is a console. Then here it is a empty space. We can open later. Okay, in console it shows all the informations. Okay, so whenever we are doing the compilations, outputs, and whatever the operations that's going to take, all are displayed here. Okay, the first step before watching this, you have to take one pen and a note and write the steps. It is useful to. Then first you have to open file, click on file and click on new, then click on workspace. Okay, file, new, workspace, then workspace will come. Okay, so before that you have to give the name of the workspace. So in this example I am going to explain all the gates in Verilog gate level modeling, so that I am giving the file name is all gates 7, like that. Then give OK. Then it's a new design wizard. In that you have to create an empty design, then give next. Then here you have to choose Verilog. Okay, default language is Verilog and target technology is not needed. Okay, this is for industrial purpose. Okay, for student it is not needed. So it is mainly used for fabrication. Okay, so the vendor name, then technology name, fabrication technology name you have to choose, but for student we not needed. Then give next. Then here it is a design name. The design name should be design 0 to design 9. I am giving design 5, like that. Okay, then next, finish. So now the workspace came. So here this is a browser, design browser. This window is a console. Then here editor window will open. So how to open? Go to file again, then new, then Verilog source. Okay, the fourth option. Then it is a new source file wizard, open. So this is a module, this rectangle indicated module. The time scale is 1 nanosecond bar 1 picosecond. Then give next. Then here your Verilog file name. Okay, all gates. Just give your workspace name, no problem. Here it is a module name. So all underscore gates, your module name. then next, then finish. Okay, so now the new Verilog editor window will open. Okay, this is editor window. So here the title is all gates, all underscore gates. Okay, our module name is also all underscore gates. Okay, then design, it's a design file, Windows user, then company name is given. While you are installing the software, you can give your name. Okay, right. Then this is a file location, then date and time. Okay, these things are available here. Then here you can write the program. Okay, first you have to give the inputs are x and y. Then outputs, how to give output. Actually here we are going to use all the gates, so to easy to understand, I am giving the output along with the gate name and O. Okay, then RO, NAND O, NOR, then XRO, XNOR, finally not O. Okay, so check all are O or 0. Okay, right, all are O's. Okay, right. Then after that, port declaration, input x comma y column. Then output. Okay, I have to write all the outputs. So instead of writing, I am just copying this. Okay, and O or O, NAND, NOR, XOR, XNOR, NOT. Okay, these are the outputs. Then next I am going to write the program by using gate level modeling. Okay, right. So first AND gate, and open bracket, and out, AND-O, input x comma y, close bracket and colon. Then OR gate, open bracket, RO comma x comma y, close bracket. Then NAND open bracket, NAND O comma x comma y. Then NOR open bracket, NOR O comma x comma y. Then XOR XORO comma x comma y. Then XNOR so XNORO comma x comma y. Then NOT O comma x. Okay, right. So these are the programs. After that, the end module is already there here. Okay, so you can see that the keywords are represented in blue color, and the remaining terms are represented in the operands. Okay, are represented in black color. Okay, right. So in that indicates we cannot use these keywords any other operands. So that I am giving AND O or O like that, the output variable name. Okay, right. After that, you go and save or Control S. Okay, Control S for saving the program. Okay, right. Now the program is saved here. Actually, the program is saved as allgates7.b. Okay, this is a file name here mentioned. Okay, right. Next we are going to do the compilation. Okay, go to design and compile. Okay, is there any error is available or not? Okay, it will take some seconds. So in console window you see the process. Okay, right. So 0 error, 0 warning. Okay, right. Now I am removing one colon here and I am again saving. Now I am compiling again. It shows the error. Okay, syntax error, unexpected token. Okay, right. Then if you click on that, if you double click on this error, then one mark is showing this instruction has the error. Actually this instruction is correct, not o comma x comma colon is correct, but here previously one colon is missing, so that indicates this line. Okay, right. Now I am update that, then saved, then again doing the compile. Okay, now it shows 0 error, 0 warning. Okay, now the compile process is over. After that, click on this. Okay, click on this plus, then you will open all gates, another one. Okay, under all gates 7.b. Okay, here you right click on this name, then select set as top level. Why we are setting? Actually in this program having only one module. Okay, if you are having so many module, then one of the modules should be top level, another remaining modules are considered as a bottom level. That means it is a sub program, considered as a sub program. Actually here only one module is there, that is considered as a top module, so that you must choose this code is top level. Here you can see the view source. Okay, so we can see the code, that will come later. Okay, otherwise you double click on this. Actually it is in open, source is opened already, so that it is not showing again. Okay, actually this is the source. Okay, right. Then after that, after choosing set as top level, you start initialize the simulation. Click on initialize simulation. Now see the console, it is doing some operations. Then after completing this process, the output signal will open. That is called structure. Okay, now it is opened. Okay, right. This is a output signals. Okay, right. Next you click on this and right click and select all. Okay, right click, select all, and again right click, add to waveform. Okay, add to waveform. Now the waveform window will open. Okay, add to waveform. Now the waveform window is open. Here the output can be the form of waveform or in the form of list. Okay, or the form of list. Okay, right. So this is a list. Initially here all gates actually have a name, right? So here you must note one thing. Actually this x and y are input, it is represented by the green color just like a NOT gate. Okay, right. The outputs are represented by opposite direction. Okay, right. So these are the outputs, these are the input, it is represented by this small green color symbol. Okay, so this is a list. The output can be viewed in the form of list, okay, or in the form of waveform, and also you can view the output in the form of watch. Okay, so this is a watch. Let me see the output. Okay, this is called watch. Okay, right. Then this is called list. These are the inputs and the remaining are outputs. Okay, right. So first you have to give the input. How to give input? So click on this x value. Okay, right. Click on the default value is z and output are in x, that is in default. Okay, so here we are going to give a input. Right click on the value. X is the first input, so the value is default in z. So right click on z and set stimulus. Then this is a stimulus name, then give OK, right. Then another one window will open. Okay, so stimulus properties, in that you have to give click on value. So by using this window you can give clock, counter, formulas, random database, okay, editable signal, text, MATLAB, etc. So in that you have to give binary value, so 0 and 1 like that. Okay, so click on that binary value and give 0, then okay. Then click on second input and the same way right click, set stimulus and it's the stimulus name and click on value. So here also I am giving 0. Okay, right. Then after that click on this run until. Actually 3 type of run is there. This is a run, okay, run until. You have to click on run until represents some time. Okay, 100 nanosecond, run until 100 nanosecond, then okay. Right, now it's executing, then it will show the output. Okay, right. Now these are the input values. Okay, right, and output values are here available. Okay, here the input and output values in the form of waveform. Click on this mark. Okay, then it will reduce the size. Okay, otherwise you can adjust by increasing the zoom. Okay, so here this line indicates logic 0. Okay, this line indicates logic 0. Okay, here this is the output, and output is 0, or output is 0, NAND is 1, NOR is 1. Okay, then XOR is 0, XNOR is 1, and NOT gate equal to 1. This is the output. Okay, right. Next I am going to change the input value. Right, then in next input value is the same method. First 0 0, then 0, again 0 1. Okay, X is 0 and actually it is a stimulus 2. Actually just click cancel and again click on that. Actually it is stimulus, then give OK, and it is again I am giving 0. Then second input it is a 1, then give OK. It's a fourth stimulus, then it is 1. Now run until, click on run until for 200 nanosecond. Right, now the input is changed. Okay, right. So first input is 0, second input is 1, then these are the outputs. These are the outputs. Similarly I am going to give a next input. Right click and set stimulus, then give OK. Then the value is 1, then OK. Then the value is here. I'm going to give 0. Then again do run until. Okay, right. Now it is a next output. Now it is next output. Okay, 3 7. So 1 0 for input 1 0. These are the outputs. Okay, here this is a watch. Then here one is list is there, na? So these are the list. For every time it will shows the output, input and output. This the form of table. Okay, right. Then finally I am going to give 1 1. Okay, already x is already 1, na? So no need to change. Then y values I am going to change. So it is 1. Now execute. Right, so this is a final output. Okay, this way we can give the input and check the output like this. Okay, right. So this is a watch window, this is a waveform window, this is a table window, that's a list window. Then here this is our console. Okay, console, this is a console. Then this is our structure. Okay, it's an output structure. Okay, right. So this way you can execute any program. Okay, this way you can execute any program, right? So it is easy process. So every time you have to verify in our program discussed in the class. Okay, then only you will get full knowledge about Verilog programming. Okay, if you have any doubts in this, you comment. Okay, send the comment. If you are first time coming to my channel, please subscribe. Okay, thank you, bye.